Hello everyone. So today we'll be studying about DFAs, that is deterministic finite automata. So I've been already been telling you about the automation. Now why do we use DFA? Okay, so automation for all machines or for all sorts of automatic things or whatever machines we are using around us, be it your compiler, be it your computer, everywhere we have been using automata. So what does automata do? It takes up an instruction that has already been trained to it, and then according to that it reacts. Now there are like the finite automata. What does this? This means that there will be a finite number of states. There will not be a role of there not be a role of many states. There will be finite number of states which pass a certain number of strings. Okay, so let's start. So finite automata mainly used for pattern recognition. What do we understand by pattern recognition? Pattern recognition means whatever we are trying to tell the compiler. If I talk about compiler, so if I go about the compiler thing. Okay, so if I go about the finite automata, so within finite automata we have this condition that we have to pass a certain string. So that is how we understand the patterns. We train the machine with a pattern and then we recognize that pattern accordingly. Now it takes a string of symbols as input and states its state accordingly. When the desired symbol is found, then the transition occurs. Okay, so whenever the symbol that accepts, okay, the finite automata will see further that whatever whatever string the automata accepts, only then our machine will go forward. Okay, at the time of transition, the automata can either move to the next or stay in the same state. So if our condition says to move on to the next step by taking a certain input, we can move further. But if we don't allow it, we can stay there only. Okay, finite automata has two states: accept state or reject state. So that final state where the machine stops taking the input, there is the accept state or the reject state. Okay, let's move further. Formal description of FA. According to this description, what we have seen is like a finite automata is a collection of 5 tuples, that is finite set of states Q. Sigma, the finite set of the input symbol, Q naught is the initial state, F is the final state, and sigma is the transition function. Finite automata can be represented by input tape and finite control. Input tape, it is a linear tape having some number of cells. Even each input symbol is placed in each cell. Finite control, the finite control decides the next state on receiving particular input from input tape. So while we can see over here this input tape, so what do we see over here? A, B, C, A, B, B, A. So like this is the string that can be read. Now tape reader reading the input symbol, and this is the finite control that comes from the D, F, A. Okay, so this is how the string is read to any finite automata. Okay, let's move further. Now there are 2 types of finite automata: deterministic finite automata and non-deterministic finite automata. Now for deterministic finite automata, as the name suggests, this is the deterministic. So we will be knowing that we will be having a unique output for every input. Please understand, a unique output for every input. Okay, and for this there can be redundant output. Okay, so while we'll be moving further with these 2 automata, I'll be just telling you, like if there is state 1 that takes 1 is input and produces state 2, there can also be a production where by taking the same input 1, the state 1 can reach to state 3. Now this is for NFA. This is for NFA. For DFA, the same thing is not possible. For DFA, the thing will be that if we are going, state 1 will produce only different outputs for different inputs. Okay, so this is the basic, like we can say, this is the basic difference amongst these. Okay. So, deterministic automata, DFA refers to deterministic finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata if the machine is read an input string one symbol at a time. In DFA, there is only one path for specific input from the current state to the next state, as we have discussed earlier. DFA does not accept the null move, that is, the DFA cannot change state without any input character. Okay, so if like in NFA it is possible that without any input character also the DFA can change its state, but in the same NFA it cannot. Okay, so formal description of DFA, as we can see, like finite set of states Q, then finite set of input symbols, initial state, the final state, and the transition function. Transition function can be described as this. Like, what is it? That every state, this transition function declares that every state, be it state 1, by taking finite set of input symbols, take it 1, will produce what? Will produce another state. Okay, so if it is state 1, like for this, if I call, if I make a DFA, then it is like state 1 is taking A as input and is producing 2 as output. Okay, so this is how for this we are creating the DFA. Graphical representation of DFA. DFA, the state is represented by vertices. The arc labeled with an input character shows the transition. The initial state is marked with an arrow. Then the final state is denoted by a double circle. Okay, so construct a DFA for the language for the string AA, B, AA over like the input symbols A, comma B. Okay, so what we can draw over here, since we are creating a DFA. Okay, so how will we go about? Let's take Q0. Q0 is taking as A. DFA we are creating. So after taking A, Q1, it will again take A, Q2, B, Q4, A, and Q5, A, B, okay. So construct a DFA for the language for the string AA, B, AA. So clearly we have created the string starts with, this is the symbol for input, for the input state, AA, B, AA. Now for making it a completely working DFA, what we have to do, we will also have to create another state, like we also have to create a situation where we have to give the B input as well. So if I go about B, Q7, okay, so this is also giving B, this is giving A, yes, and similarly this will produce A. This will produce B. Okay, so this is how, now this is the trap state. Okay, so we are creating, now if I take about the same string, let's try and pass over the same string. Okay, so A, if the string is AA, B, A, A. So this is a very little trick to check whether the string can be passed or not. So if Q0 is taking input as A, so what is it getting? Q1. Now Q1, when it takes input as A, it goes to Q3. Okay. Then Q3, when takes B input, it reaches Q4. And then Q4, when it takes input as A, it reaches Q5. And when Q5 state takes input as A, it reaches Q6. That is the final state. Now this is the final state. Okay, so this is how we check. Whether we can reach to the final state by taking a certain input or not. Okay, so this is that input string that we take as the input tape. So as we discussed the DFA today and the basic properties of DFA, we'll be moving further the different examples for DFA. Okay, how do we carry forward? How do we make different DFAs? Sorry. Now, here is it. Construct a DFA over A comma B where length is equal to 2. Okay, so we make the final state. We make the initial state. State A, then state B, then A, then another state, okay. So this is the trap state. First of all, this is the trap state, and this is for where length is equal to 2. Length is equal to 2. What does it mean? Now, if A is taking A as input or B as input, it is reaching to state B. Now, this becomes to length 1. Okay. Then, if B takes A as input or B as input, then length becomes and hence we reach the final state, that is C. Furthermore, we are doing it that in case if we get more inputs, then the machine goes into the trap state. Okay. So construct a DFA where the length is at most 2. Now what do we mean by at most 2? That maximum the length can be 2, minimum it can be 0, or it can be 1, or it can be 2. This should be the length. Okay. Okay, so we go about this at most 2. Now what does this mean? That maximum it can reach to, else it can be less also. So if we go about A takes input as A or B and B takes input as A or B, it reaches to point C. Furthermore, if it goes, it can also create A or B and it can create most of the length of the string, that can be maximum 2. For at least 2, that means minimum it can go to and it can go maximum to any length. Okay, so similarly, like minimum it can go to, like it has to be there, it should be there, that minimum there should be length 2, and then further it goes about whatever it can be. So that means that if I pass a string called A, so what happens is capital A will reach capital A after taking input as A will reach to state B. B after taking input as A will reach to point C. So this is how A comma A is equals to B and B comma A produces C. So the length and the string gets passed, we reach the final state, and that's how length is 2. Okay, so this is at least 2. Maximum, like if I go beyond A. So now after C also takes A as input, it reaches to D. So it can be further. In any cases, whatever you want, it will go. Okay. Construct a DFA where the length is even. Okay. So for the length is even, we create okay. So there are these 2 states that I've taken. Okay. So what we do is okay, and we pass it with input A comma B okay, and the final state will be A. Okay, so how was that possible? For example, take the string to be AA or 4 times A. Now, when A takes input as A, it reaches to B. A, when takes input as A, it reaches to B. And when B takes input as A, it reaches back to A. That's how the length of the string will be 2 or even every time. The state, the machine, we can take it as M1. Now this M1 machine will run only for even length of the strings. Okay, it will run minimum 2 times every time we run it according to our string. Okay, and same if we want to draw A and then B. Okay, then this is the M2 machine that is producing single length of the string, single length or the odd length. Okay, like we can get the output as, if I say A or AAA, so within single input I'll get obviously like A comma A, I'll get B, and B is the final state, so A is accepted. Okay, and if I go about B comma A, okay, so if I have A comma A, it will reach to the final state B, and if further I have B comma A, it will go about if we have further B comma A, it will go about A, and then further once again we'll be having okay. So this is how we get odd length of string. Okay. Next, construct a DFA that's where the string starts with A and hence again that ends with BB. So starts with AA, that means Q naught. Okay, it produces A. Okay, so now if it takes B, we can put it in here or this, and Q2 can have any combination of A and B. No. Okay, so this is how AA, any combination of B, and if it gives an input B, so we can have the Q3 as the trap state. Okay, then we come to when the string ends with BB. So that means it can start with anything, but it has to end with BB. So I take it as A and B. Okay, and this has to be the final state, and this can be the trap state that has A comma B with it, and we are having this way. Okay, this also has to be A comma B. Okay, so we have this A B B where we are reaching to the point A and then we are ending it with a B. Okay, thank you.